Okay, dear students, now we are going to the chapter-wise concept. The topic is theory of equations. Okay, now we are going to the polynomial or expression. That means the theory of equations depends upon the polynomial. Polynomial means it is maybe first degree, second degree, third degree, fourth degree, fifth degree, whatever it may be. That's why expression, there is difference between expression and equation, and polynomial and polynomial equation. Suppose we have to take f of x taken as expression, it is called polynomial. If f of x is equal to 0, then it is called equation. At the same time, it is also called polynomial equation. If the expression is equal to 0, it is called equation or polynomial equation. Just f of x is there, that is called expression or polynomial. Now we are going to first polynomial. Let f of x is equal to a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus a3 x power n minus 3 plus so on plus an minus 1 x plus an is called polynomial of degree n, or is called nth degree polynomial. Is called nth degree polynomial. Is called nth degree polynomial. Nth degree polynomial or expression, or it is called expression. Are you clear? Where a naught not equal to 0, comma a1, comma a2, a3, so on, an minus 1, an are constants, with a real variable x, with a real variable x, with a real variable x. Is it clear? That's why this is the polynomial of nth degree, or this is the nth degree polynomial where the coefficients are called constants. Constants means which may be real numbers or imaginary numbers. That's all. Now x is the variable. That's why this is the single variable polynomial. Are you clear? So it is with a real variable x. X is variable. Now for n is equal to 1. For n is equal to 1. F of x is equal to a0 x plus a1. Here, where n belongs to capital N, n is natural numbers. That means positive integers. So f of x is equal to a0 x plus a1 is called first degree or linear polynomial. Is called first degree. Is called first degree or linear polynomial. Linear polynomial. First degree or linear polynomial, such that a naught not equal to 0 comma a1 are constants. Now, for n is equal to 2, f of x is equal to a naught x square plus a1x plus a2 is called second degree second degree polynomial or quadratic polynomial That's all. Here also a naught not equal to 0, a1 comma a2 are constants. Now, for n is equal to 3, f of x is equal to a naught x cube plus a1 x square plus a2 x plus a3 represents third degree polynomial or cubic polynomial. Is called third degree or cubic polynomial where a naught not equal to 0 comma a1 comma a2 comma a3 are constants. Okay, next, for n is equal to 4, f of x is equal to a naught x power 4 plus a1x cube plus a2x square plus a3x plus a4 is equal to 0 is called fourth degree or biquadratic polynomial. Where a naught not equal to 0, a1 comma a2 comma a3 a4 are constants. For n is equal to 5, f of x is equal to a naught x power 5 plus a1 x power 4 plus a2 x cube plus a3 x square plus a4 x plus a5 is called fifth degree polynomial. Fifth degree polynomial where a0 not equal to 0, a1 comma, a2 comma, a3, a4, a5 are constants. That's all. So this is the formation of polynomial or expression. Polynomial or expression. That means linear expression which contains one variable and maybe two constants. That means a1 and a0 and a1 are constants. They may be real numbers or imaginary numbers. Such that means the coefficient of x is 0. It is not a linear polynomial. That's why coefficient of x not equal to 0. For second degree polynomial, coefficient of x square not equal to 0. Suppose coefficient of x square is equal to 0, then this is not a second degree polynomial, then it is a linear polynomial. Now here, for n is equal to 3, it is cubic polynomial. For cubic polynomial, definitely the coefficient of first term must not equal to 0. Since if it is 0, then it is a second degree polynomial. That's why, so the degree of the polynomial definitely depends upon the coefficient of higher term must not equal to 0. So these are the polynomials or expressions. These are the polynomials or expressions. That's why, so for these polynomials, we have to identify the zeros of the polynomials. Zeros of the polynomials means what? The value, that means x satisfy the polynomial, x satisfy the expression. If x satisfy the expression, then the value is called, the value of x is called zero of the polynomial. Now, zeros of the polynomial. Zeros of the polynomial. For example, we have to take one example. F of x is equal to x minus alpha. F of x is equal to x minus alpha is a linear polynomial. Is a linear polynomial. Is a linear polynomial. Is a linear polynomial. Okay. For this, f of alpha is equal to alpha minus alpha. That is 0. That's why f of alpha is equal to 0. Therefore, alpha is the 0 of x minus alpha. Alpha is the 0 of f of x or x minus alpha. Now example 2. Example 2. F of x is equal to x minus alpha into x minus beta is a quadratic polynomial. Is a quadratic polynomial. Quadratic polynomial. Quadratic polynomial. For this, we have to find the zeros. What is f of alpha? Here alpha minus alpha 0. What is f of beta? Beta minus beta 0. That's why, therefore, alpha comma beta are the zeros of f of x. Zeros of the polynomial. Zeros of the polynomial. Is it clear? So, from this, suppose here for this one example, x plus 2. Here we have to take f of x is equal to x plus 2. F of x is equal to x plus 2. For this, f of minus 2 is 0. That's why minus 2 is 0 of f of x. For this one example, f of x is equal to x square minus 3x plus 2. Now for this one, f of x is equal to, that means f of 1 is equal to 1 minus 3 plus 2, that is 0. And f of 2 is equal to 4 minus 6 plus 2, so that is 0. That's why here 1 and 2 are zeros of f of x. Are you clear? That's all. Like that. Now f of x is equal to example 3. F of x is equal to x minus alpha, x minus beta, x minus gamma is cubic polynomial. Cubic polynomial for this. F of alpha is equal to 0, f of beta is equal to 0, f of gamma is equal to 0. That's why alpha, gamma, beta, gamma are the zeros of f of x, zeros of the polynomial. So that's why this is called zeros of the polynomial. That's why for expression or polynomial there exist zeros. For expression or polynomial we have to find zeros. Means what? The value of x is satisfied. That means it gives a remainder is 0. It gives remainder is 0. So these are the factors as well as zeros. Right? That's all.